Hi friends, welcome back to another session on the operating systems. So in this session, let us look in detail about the operating system operations. So basically, in the modern computing system, the operating system works in dual mode, and the dual mode is basically designed to provide a layer of protection and stability to computer systems by separating the user programs and the operating system into two different modes. User programs are written by the users who are not very much specialized in writing the code, may not be experts in writing the code, so they may create some unstable code so that it may disturb the whole system. But as far as the writers or the code writers of the operating system are concerned, they are experts, and hence the chances of committing mistakes are almost zero. So all serious actions are taken to ensure that no errors pass through any security gate so that everything works perfectly. But as far as the user is concerned, a common man is concerned, or a simple programmer is concerned, we can't guarantee that. Therefore, it is better to keep the user uh, not having all the facilities to interact with the actual hardware and all the main facilities. So we can ensure security through making two modes of operating system of work, one under the user mode and one under the kernel mode. The user mode, usually the applications through which the user interacts, and these applications and the code written by the user work under the user mode of the operating system. And under this mode, the access is restricted to the core functionalities of the system so that it is not allowed to interfere the system's working. So by mistake or by any uh, harming intention, a user may write some code which may disturb the overall functioning of the system. So to ensure this security, only the user level activities are allowed to function, and these activities that are working in user mode can interact with few components like compilers, user applications, and may use system libraries using the system calls. But on the other side, we have all the hardware and the control code that is part of the operating system that is used to control the hardware that is actually using the hardware. So if we are working in this mode, then we have all the facilities, all the privileges to directly access the hardware and other system resources. Because the operating system components which are written in the kernel mode or which are allowed to work in the kernel mode have gone through a series of filtering, a series of testing and all that, so that they are 100% foolproof, and hence they are allowed to interact with the CPU, RAM, hardware, and other resources directly. Whereas if it is the user mode applications, then the hardware can be accessed only through the tasks that are working in the kernel mode. So if user wants to compile anything, then it has to use a compiler, but the compiler is working in the user mode. And if compiler wants to compile the code, then it has to send a request. That request is called a system call, and that system call enables the kernel module, and that kernel module, if the system call is genuine and it is authenticated, then the kernel module will allow the hardware and other system resources to be used. So this way we can ensure security. So no system user defined functions can disturb our overall system. So that's way we ensure that the whole system is secured. Then there is a possibility that the user program may get into sometime infinite loop. So when any user program gets into infinite loop, so like an example, maybe the earlier initial versions, anyway we are trying to divide, then usually the division process is done through subtraction, because at the hardware level there is no hardware available for division and multiplication. We have addition and subtraction hardware for that. Therefore, if we want to multiply two numbers, then we keep adding the one number to itself by another number of times. Say if I want to multiply a with b, then a gets added a plus a b number of times, and after adding a b number of times we get a into b. Same way, if we want to divide a by b, then we keep subtracting b from a, and then this difference we again use, and that is used to subtract again by b. So we keep subtracting b, and count how many times we subtract b, and at the end when we reach 0, then we just look at the count how many times the b was subtracted, and that count gives the answer a by b. But the question comes is, if b is equal to 0, then a minus 0 is a minus 0 is a minus 0 is a. It will never go down to 0. Therefore, this loop continues forever, which we call an infinite loop. So similar way, today we understood that if anywhere we are trying to divide, first we make sure that the divisor is 0 or not. If it is 0, we stop execution itself. If it is not zero, only then we continue. So this just we stop whenever we get a dividing operation. We just stop and see what is there at the divisor level. If it is zero, we don't divide. If it is not zero, then the division process is continued. But there can be some issues in our user program where it may end up with an infinite loop. Like if we are going to use something like a while loop, and if we say while a goes greater than 0, we just continue. So if we start from a negative number and then keep adding some positive number to that, then from a negative number getting added positive numbers, after a few number of times it will cross 0 and then we can stop it. So, otherwise, if you are saying that you are just trying to continue the loop only when the value is positive, that means while a is greater than 0, repeated. In that case, we need to make sure that we start with a high positive value and then keep subtracting some positive value from that. And so, because of that, it goes down, 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 and sometime it process is 0, which stops the process. But by mistake, we are looking for stopping as a negative number. So we just write that while a greater than 0, repeat the following set of code, and we start a with a positive number, and in each iteration we keep adding another positive number to that. Then it will never get into negative side. It will never reduce, and it keeps on increasing and increasing, and all the time it remains in the positive side only. And because it is in the positive side, the loop continues. And by mistake it has happened, we wanted to subtract a positive number, but we added a positive number by mistake, and this gets into an infinite loop. So there is possibility of the human error. Then the program may continue to run forever, and it is the operating system's duty to ensure that the program, the user program, should not work forever. So it should somehow prevent these infinite loops. So this is done by periodically interrupting a program's execution and allowing the operating system to regain the control. So just make sure that if it is going round and round, then you ensure that the operating system interrupts the process. So you just imagine that we have some code written here which is getting into an infinite loop, and then when this code is started to run same time, and timer is also initiated, and we know on average, on the worst case, what could be the user mode code takes to run. So if we know that in the worst case how much time any user program can take to run, then we can just create a timer of more than that time and just wait. And within that time, if the loop completes, then no issue. But even after this interval of time, if the loop does not complete, that means this might have gone into an infinite loop. So to stop this, the interrupt has a counter, and it just keeps counting the time, and when the time is up, it interrupts the process and then gets back to the operating system and says this process was running and it run out of time, and hence it was interrupted. Either user should interfere and see what went wrong, correct it. Otherwise, each time it comes out the same way, because if it is any human mistake in coding, then human has to interfere and then correct the mistake. Or if it is happening because of some unavailability of the resources and all, then it may restart automatically and then again can wait for this every time a timer begins, and after a scheduled time, if it doesn't complete, then again it interrupts and operating system interferes and gets the control and continues. Then one major confusion or wonder is, how does a computer starts working? How does a computer starts working? Because as we know that the operating system stays in the back end, that is in the secondary memory, until it comes on to the main memory, the computer cannot start working. And the problem is how to get the operating system onto the main memory. That's the biggest challenge. And that big challenge is taken care by the bootstrap effect, that is pulling itself up. That means that we need some process that initiates automatically. So we just have one uh, BIOS, basic input output software system, whatever we can call, which is hard stored in something like a EPROM, and this EPROM is part of the motherboard. And when we switch on the computer or when we restart the computer manually, then by default the address is reset to some constant value, and the process will start loading from the address which is by default starts, and that default address is pointing to another small code which we call a loader. A small code which is dumped into a small memory, EPROM, which is non-volatile memory, and it stays with the in the chip, so it doesn't gets deleted even when there is no power supply. So it's a non-volatile memory, and then whenever we switch on, then automatically the processor address gets to the by default address, and that default address is pointing to the BIOS, and this BIOS is a loader, and this starts running. And once this starts running, what is it doing? It looks where the operating system is in the secondary memory, and that from there it start loading the operating system from the secondary memory to the main memory. Byte by byte, byte by byte, it reads from the secondary memory, dumps onto the main memory at a particular location decided in the beginning in the by the system developer, and this whole thing gets dumped onto the main memory. That is done by the bootstrap loader. And what actually happens at this level is a small part of the operating system which we call the kernel gets loaded first. So overall, first what happens is when we switch on the BIOS on the EPROM, gets start functioning, which is a bootstrap loader, and that loads from the secondary memory onto the primary memory the kernel, a small part of the operating system that is sufficient to keep the system active. That means it will allow keyboard active and then the display. So the keyboard and the display are turned on. So that's what beginning of the session. So when the kernel gets onto the main memory, then the transfer of the control is transferred to the main memory, that is the kernel, and the kernel now starts running. And once kernel starts running, it gathers other information, that is what all the components are connected to our system, maybe the peripherals, maybe uh, other devices like the mouse is connected or the any other pen drive is connected on all that. So whatever peripherals are connected to our system, it identifies what all are connected, and to work with them we need a driver software. So it gathers the information what drivers are required to interact with the peripherals, and searches in the secondary memory where these drivers are available, and those drivers are loaded onto the main memory. And this whole thing happens whenever we switch on a computer. So when we switch on the computer, first part, the loader starts working. The loader is called the bootstrap loader or the basic input output system, which is stored in the EPROM. It starts running, and this EPROM is a small code which loads the kernel code of the operating system onto the main memory. After loading the kernel code onto the main memory, the transfer of the processor is shifted to the main memory. Now onwards, the contents of the main memory are being executed. So till now, the contents of the BIOS or the EPROM code was being executed, and once this kernel is loaded onto the main memory, the control is transferred to the main memory kernel component of the operating system, and hence now onwards the kernel takes the authority and it starts running. And the first activity kernel does is searches all the components connected to our motherboard, and then driver for each of them is loaded onto the main memory, and then the whole full-fledged operating system comes to active mode. So looking at what kernel boot system is, it's a process of starting a computer and loading the operating system into the memory and making computer ready for use. So when we power on the computer, the BIOS performs the post, and then from the disk to the RAM, the operating system is loaded. So that's in general we can speak up, but more detailed version. So whenever PC is turned on, the BIOS is loaded, and this BIOS will run, and from the zero disk the code is loaded and that is run, and then this boot sector code looks for and runs the boot manager, and then the details of the operating system are dumped onto the main memory. So other way, in total if you look at it. So it's first thing is the boot is BIOS is loaded, then power on self test, which is what we call POST, is then completed. So it just looks what all components are there, whether keyboard is connected or not, and display is connected or not. So without display, there is nothing we can do. Without keyboard, nothing we can do. So two things are essential to begin with, and today even mouse also has become essential. So before working, so if keyboard is there, then we can start working. If keyboard is not there, what should I do with that? So when there is no keyboard, and if the display shows, what can I do? I can't tell anything to the system what to do. So minimum keyboard is required, or I need a mouse to begin through the GUI, or if I want to use CLI, then keyboard is essential. So without that, there is no meaning. It so first it will check, do we have all the basic required things? If yes, then start loading the operating system and then configure the system accordingly. That means just look at what all components are there connected to our system, and then all the drivers and all are loaded, and then if they are properly configured, and then utilities are loaded, and finally the user is authenticated. Only after that user is allowed to use the system. So that's all the operations, the early operations any operating system will do. So that's some details about the various operations performed by the operating system at the basic level. Many more issues to discuss in the coming sessions of this series. So please keep watching. Please like this video and then subscribe to the channel, and please hit the bell icon so that the coming videos you will get a notification. Hope you are enjoying this session. So keep watching. Thank you.